Nowadays, when people in the West think of Russian technology, the first images that come to mind are military equipment or old Soviet aerospace triumphs. But what most people don't realize is that Russia has quietly been developing something with the potential to reshape not just its own energy system, but possibly influence future aerospace engineering as well. It's known as the GTD-110M, the first turbine fully designed and built inside Russia. And, don't assume this is just another heavy industrial machine. Its capabilities are far more impressive than they appear. So, why does this turbine matter so much? How does it outperform Western alternatives? Let's break it down. To understand the importance of the GTD-110M, we need to consider the pressure and uncertainty Russia has faced over the past few years. For decades, the country's energy grid relied heavily on gas turbines developed by Western technological giants like Siemens, General Electric, GE, and Alstom. These engines powered plants across Russia, delivering electricity to millions of homes and industries. This partnership seemed stable and irreplaceable until everything changed. After Russia launched its special military operation in Ukraine, a wave of international sanctions hit, cutting the nation off from global tech supply chains. Western firms pulled out of the Russian market, making turbine purchases, servicing, and replacement parts nearly unreachable. This wasn't just an economic setback, it was a direct threat to Russia's energy stability. Hundreds of power stations were suddenly at risk of shutdowns or severe performance drops without support or spare parts. Faced with this crisis, Russia had two choices: accept vulnerability or build its own solutions. They chose to push forward. Out of this pressure, and the drive for technological self-reliance, the plan to create a large-capacity domestically produced gas turbine gained momentum. The GTD-110M wasn't simply a strategic decision, it became a necessity for Russia to protect the stability and sovereignty of its energy sector. In 2024, the turbine officially entered service at the Udarnaya power plant in southern Russia during a ceremony attended virtually by President Vladimir Putin. His comments summed up the moment clearly. The fact that we have new production facilities and that we are becoming technologically sovereign, at least in this area, is very important. Putin personally overseeing the launch emphasized how crucial this achievement is for Moscow. This wasn't just an engineering success, it became a symbol of industrial independence. So, what makes the GTD-110M so unique? Things are about to get even more interesting. But before we continue, make sure to like, share, and subscribe. Thank you. At first sight, the GTD-110M looks like a standard industrial gas turbine, an enormous machine sitting inside a power facility. But don't let its size fool you. This turbine is far from ordinary. It represents a remarkable piece of engineering forged under extreme pressure, a declaration of technical self-reliance, and it contains surprises that challenge perceptions of Russian innovation. Let's reveal what sets this machine apart and why it's turning so many heads. The first surprise: it can power an entire city. What do you expect one machine to do? The GTD-110M is no small performer. It's a powerhouse, literally. It can generate enough electricity to supply tens of thousands of households or keep major industrial plants running around the clock. At the Udarnaya power station, it increased total output from 454 megawatts to a massive 560 megawatts. That means this single turbine alone provides roughly 10% of the electricity needed for a large region like Krasnodar. This is not just about energy output, it's about national energy security. The second surprise: smaller, lighter, yet extremely capable. Usually bigger machines deliver more power, but the GTD-110M proves the opposite. Compared to similar Western-made turbines, this Russian model is lighter and more compact. That might sound minor, but it's a major strategic advantage. The reduced size simplifies transportation, installation, and integration with existing energy systems, cutting down both time and costs. What's more impressive is this. Despite being smaller, Russian engineers confidently state that its performance matches, and in certain aspects even surpasses, its Western competitors. That points to smart design choices and advanced material engineering. It's not a copy, it's an improvement. The third surprise: designed for efficiency. In engine technology, efficiency is everything. Every percentage point of improvement saves enormous operating costs over the years. This turbine was engineered not just to operate, but to operate intelligently. Russian engineers prioritized making a system that uses less fuel while producing more electricity. This matters economically and environmentally, aligning with global sustainability demands. It shows that Russia wasn't interested in building a simple replacement, they wanted to build a superior product. The fourth surprise: built to endure harsh conditions. For an engine to succeed, It must survive extreme environments. Russian developers created specialized components that can tolerate massive temperatures and pressures, allowing the turbine to run reliably even under the toughest conditions. This durability also cuts down on maintenance, an enormous benefit for long-term stability and cost control. This turbine wasn't just manufactured, it was forged to endure and overcome. The final surprise, 100% made in Russia. From the earliest blueprint to the final bolt, every part of the GTD-110M was produced domestically. For Russia, this goes beyond national pride. It represents a strong statement of technological independence and, honestly, a buffer against future supply chain turbulence. As the world attempts to isolate Russia technologically, the GTD-110M stands as proof that the country can not only adapt, but also innovate and advance. This turbine is the new beating heart of Russian industry, built entirely by their own hands and expertise. Aviation Breakthroughs. Now you might ask, what does any of this have to do with aviation? Don't be deceived by the turbine's industrial appearance, because it hides something that could influence the future of Russian aerospace. This is the element that has sparked the most curiosity. Many believe the GTD-110M isn't just an energy milestone. It's a strategic weapon for aviation research. Although it was designed for power generation, aerospace engineers are paying attention for one simple reason. Its core traits almost perfectly match the requirements of a modern jet engine. Let's break these down. First, its lightweight structure and strong efficiency. Modern aircraft engines must be light to extend range and reduce fuel burn. The turbine has already demonstrated this with its compact design, all while maintaining performance equal to or better than Western models. Next, its resilience. Jet engines must survive extreme environments, blistering heat, sudden temperature drops, and low-pressure conditions. Russian engineers crafted components for the GTD-110M capable of withstanding intense heat and pressure, ensuring stable operation, exactly what aircraft turbines demand. Finally, fuel efficiency. Just like aviation engines, the GTD-110M is engineered to use less fuel while producing more power. These improvements directly contribute to future aircraft flying farther and more economically. Of course, the GTD-110M itself won't be mounted on a passenger plane anytime soon, but the research behind it, new heat-resistant materials, precision engineering, and advanced aerodynamic principles can be applied immediately to Russia's next generation of jet engines. At a time when Russia is rebuilding its civil aviation sector without Western support, having a domestic R&D foundation like this is a major advantage. Its breakthroughs form the groundwork for future innovations in aerospace. Challenges and long-term impact. The turbine's success marks a major turning point, but the road forward is still full of challenges. Russia must close its technology gap with Western competitors and scale from a single successful model to a reliable, high-volume industry. Designing a large gas turbine is one of the hardest engineering tasks any nation can take on, and Russia learned this the hard way. For example, in 2017, early testing ended with a prototype explosion. It was a brutal reminder of the complexity involved. Everything, from creating materials that handle extreme heat to achieving millimeter-level precision, must be flawless. But instead of discouraging Russia, these setbacks became motivation. Engineers pushed harder, refining both the design and the manufacturing process. The GTD-110M's eventual success stands as proof of persistence, adaptation, and learning from failure. Still, building one turbine is one challenge. Producing them at scale is another. Rostec plans to manufacture at least 4 units per year, but reaching that goal requires massive investment, advanced facilities, cutting-edge equipment, and skilled personnel. Guaranteeing long-term reliability and matching Western performance standards is another mountain to climb. Moreover, being excluded from global supply chains slows down Russia's ability to innovate. They now must develop everything domestically, from specialized alloys to high-grade electronic systems once imported. This is both a heavy burden and a powerful incentive. Significance. For Russia, the GTD-110M is more than a machine. It's a message, a declaration that the country can produce complex technologies without relying on outsiders. Its success may allow Russia to emerge as an independent global supplier of large gas turbines, competing with companies like GE and Siemens. If the innovations from this turbine carry over into aviation, it could give Russia a long-term strategic advantage, especially as the aviation world demands greater fuel efficiency and sustainability. Breakthroughs from the GTD-110M may help Russia develop a new generation of competitive aircraft engines. One thing is clear: this turbine has changed the conversation. It proves that even under isolation, determination and creativity can lead to major breakthroughs. And if an industrial power plant engine can inspire hope for the aviation sector, we can expect more surprises from Russian technology in the future. The GTD-110M is a story of resilience, innovation, and perseverance. Born from immense challenges, it shows that Russia can push through adversity to create advanced engineering solutions. Do you think this turbine can truly compete with the West? How would you evaluate the capabilities of Russian engineers based on this achievement? Let's talk in the comments below. Thanks for watching, and stay safe.